Today we're talking about J.J. Thomson, who discovered the first particle inside of an atom. Remember, we were talking about Dalton last time, and he thought that the atom was a solid sphere. And this is about early 1800s, about 1803. But scientists discovered this new phenomenon where if you have a pure element alone in a drawer, it began emitting energy, and they saw that this energy could go through film and develop pictures. So usually you had to use light to develop film. So knowing that, they knew that that atom that made up those elements had to be emitting some kind of energy that would then go through the film to develop a picture. So their explanation was that atoms must be giving off some sort of particle and some sort of energy. So now scientists were looking to figure out what those particles are. There are radioactive elements. Those are elements that decay and they emit particles and energy as they do that. Madame Curie and her husband, Pierre, were two individuals who were researching radioactive elements, and they discovered two, radium and polonium. And those two elements will decay and they give off particles and energy as they decay. So the first particle was discovered by J.J. Thomson, and he used a cathode ray tube. So you notice this is after Dalton. A cathode ray tube has a power source at one side. That power source has a cathode and an anode. The cathode is that negative side, and the anode is a positive. And then here you have a cathode on this end. So here, if you turn the power source on, it emits this beam of electricity straight through the tube. He found out if he held up a magnet, so if you put a negative magnet on this side, then that negative magnet, even without the positive one down here, would make the beam curve and deflect it, right? And so hopefully you remember what happens when you put like charges together. If you put like charges together, they'll repel. All right, so this was a sign that this beam is actually negative because it's repelled by a negative magnet. It was also, if he held up a positive magnet, it was attracted to the positive magnet. And maybe you remember that like charges attract. So a negative beam here would be attracted to a positive magnet. So what did he observe? He found out that particles will respond to that electricity when there's no magnet applied. The particles just go straight, that beam just goes straight ahead. But then if a magnet is applied, that the electricity is pulled toward the positive magnet or it's pushed away from the negative one. So that means that those particles inside of that electric current must be negatively charged. So in the electric current, opposites attract. Those particles are moving toward the positive magnet and away from the negative one. This particle is not radioactive. It's only emitted when an electric current is applied. So the particle is in that electric current. The particle is negatively charged, and the particle is really, really small. The particle has a lot of electric charge per mass. So coulombs is a way to measure charge. It's a really big number, times 10 to the 8th. So it has a lot of charge per just 1 gram of it. You'll notice this is a conversion factor that lets him convert between coulombs and grams. So if you know how much mass you have, you can convert to coulombs, or if you know coulombs, you can convert to grams. With this knowledge, J.J. Thomson developed his model of the atom. It was a positive sphere. So now remember, Dalton has that solid atom. Now we're going to a sphere with negative electrons sprinkled in it. So here are your negative electrons. And he thought that the rest of it was like a positively charged substance. So you can think of it as a watermelon, where the electrons are the seeds of the watermelon, and the positive charge is just like everything else, the fruit of the watermelon. Okay, so let's compare a little bit. I kind of just did this, but so Dalton's theory was that you have an atom that is a solid sphere. And he also thought that you couldn't get any smaller than that atom. Like that was the smallest you could get. So that was proven wrong. It was a starting point, though. Thomson's model contains another smaller particle, so it's got the electron in it. The atom has a charge, and there are positive areas in the atom, and those charges actually will cancel each other out. So overall, yes, the atom is made up of charged particles, but the positives and negatives will cancel each other out so that you get a neutral atom overall. But there are small negative particles scattered throughout the positive area. For similarities, they both have the atoms are tiny particles as a whole, right? The whole atom is really small. All matter is still made up of atoms. They both believe that. Different elements have different atoms. That's still something that both of them believed. And atoms can combine to form compounds. All right, we'll pause there.